Introductory Chemistry, provided by the University of California LibreText Project. Chapter 1, Chapter Overview. 1. The Chemical World. Chemistry is the study of matter and the ways in which different forms of matter combine with each other. You study chemistry because it helps you to understand the world around you. Everything you touch or taste or smell is a chemical, and the interactions of these chemicals with each other define our universe. Section 1.1, The Scope of Chemistry. Chemistry is the study of matter and the ways in which different forms of matter combine with each other. You study chemistry because it helps you to understand the world around you. Everything you touch or taste or smell is a chemical, and the interactions of these chemicals with each other define our universe. Chemistry forms the fundamental basis for biology and medicine. Section 1.2, Chemicals compose ordinary things. Chemistry is the branch of science dealing with the structure, composition, properties, and the reactive characteristics of matter. Matter is anything that has mass and occupies space. Thus, chemistry is the study of literally everything around us: the liquids that we drink, the gases we breathe, the composition of everything from the plastic case on your phone to the earth beneath your feet. Moreover, chemistry is the study of the transformation of matter. Section 1.3, Hypothesis, Theories, and Laws. Although many have taken science classes throughout the course of their studies, people often have incorrect or misleading ideas about some of the most important and basic principles in science. Most students have heard of hypotheses, theories, and laws. But what do these terms really mean? Prior to reading this section, consider what you have learned about these terms before. What do these terms mean to you? What do you read that contradicts or supports what you thought? Section 1.4, The Scientific Method, How Chemists Think. Science is a process of knowing about the natural universe through observation and experiment. Scientists go through a rigorous process to determine new knowledge about the universe. This process is generally referred to as the scientific method. Science is broken down into various fields, including chemistry, and is both qualitative and quantitative. Section 1.5, A Beginning Chemist, How to Succeed. Most people can succeed in chemistry, but it often requires dedication, hard work, the right attitude, and study habits. Section 1.E, Exercises for Chapter 1 of Troll's Introductory Chemistry Text Map. Section 1.1, The Scope of Chemistry, Learning Objectives, to recognize the breadth, depth, and scope of chemistry, define chemistry in relation to other sciences, identify the main disciplines of chemistry. Chemistry is the study of matter, what it consists of, what its properties are, and how it changes. Matter is anything that has mass and takes up space. That is, anything that is physically real. Some things are easily identified as matter. The screen on which you are reading this book, for example. Others are not so obvious. Because we move so easily through air, we sometimes forget that it, too, is matter. Because of this, chemistry is a science that has its fingers in just about everything. Being able to describe the ingredients in a cake and how they change when the cake is baked, for example, is chemistry. Chemistry is one branch of science. Science is the process by which we learn about the natural universe by observing, testing, and then generating models that explain our observations. Because the physical universe is so vast, there are many different branches of science. See figure 1.1.1 on page 1.1.1 of the text. Thus, chemistry is the study of matter, biology is the study of living things, and geology is the study of rocks and the earth. Mathematics is the language of science, and we will use it to communicate some of the ideas of chemistry. Listed are math, physics, astronomy, chemical physics, chemistry, biochemistry, geochemistry, biology, geology, medicine. Figure 1.1.1 The relationships between some of the major branches of science. Chemistry lies more or less in the middle, which emphasizes its importance to many branches of science. Although we divide science into different fields, there is much overlap among them. For example, some biologists and chemists work in both fields, so much that their work is called biochemistry. Similarly, geology and chemistry overlap in the field called geochemistry. Figure 1.1.1 shows how many of the individual fields of science are related. At some level, all of these fields depend on matter because they all involve stuff. Because of this, chemistry has been called the central science, linking them all together. There are many other fields of science in addition to the ones biology, medicine, etc., listed here. Example 1.1.1 Science fields. Which fields of study are branches of science? Explain. S- se- um, Choice A, sculpture. Choice B, astronomy. The solution. As for choice A, sculpture is not considered a science because it is not a study of some aspect of the natural universe. As for choice B, astronomy is the study of stars and planets, which are part of the natural universe. Astronomy is therefore a field of science. Exercise 1.1.1 Which fields of study are branches of science? Choice A Physiology, the study of the function of an animal's or a plant's body. Choice B, geophysics. Choice C, agriculture. Choice D, politics. As for choice A, physiology, the study of the function of an animal's or a plant's body, the answer is yes, it is a branch of science. As for choice B, geophysics, the answer is also yes, it is a branch of science. As for choice C, agriculture, the answer is yes, it is a branch of science. As for choice D, politics, the answer is no. It is not a branch of science. Areas of chemistry. The study of modern chemistry has many branches, but can generally be broken down into 5 main disciplines or areas of study. Physical chemistry is the first. Physical chemistry is the study of macroscopic properties, atomic properties, and phenomena in chemical systems. A physical chemist may study such things as the rate of chemical reactions, the energy transfers that occur in reactions, or the physical structure of materials at the molecular level. Organic chemistry. Organic chemistry is the study of chemicals containing carbon. Carbon is one of the most abundant elements on Earth and is capable of forming a tremendously vast number of chemicals, over 20 million so far. Most of the chemicals found in all living organisms are based on carbon. Number 3, inorganic chemistry. Inorganic chemistry is the study of chemicals that, in general, are not primarily based on carbon. Inorganic chemicals are commonly found in rocks and minerals. One current idea of inorganic chemistry deals with the design and properties of materials involved in energy and information technology. Number 4, analytical chemistry. Analytical chemistry is the study of the composition of matter. It focuses on separating, identifying, and quantifying chemicals in samples of matter. An analytical chemist may use complex instruments to analyze an unknown material in order to determine its various components. And number 5, biochemistry. Biochemistry is the study of chemical processes that occur in living things. Research may cover anything from basic cellular processes up to understanding disease states so that better treatments can be developed. On page 1.1.3, you will find figure 1.1.2 left. Measurement of trace materials. Again, measurement of trace metals using atomic spectroscopy. And on the right, measurement of hormone concentrations. In practice, chemical research is often not limited to just one of the 5 major disciplines. A particular chemist may use biochemistry to isolate a particular chemical found in the human body, such as hemoglobin, the oxygen carrying component of red blood cells. He or she may then proceed to analyze the hemoglobin using methods that would pertain to the areas of physical or analytical chemistry. Many chemists specialize in areas that are combinations of the main disciplines, such as bioinorganic chemistry or physical organic chemistry. History of chemistry. The history of chemistry is an interesting and challenging one. Very early chemists were often motivated mainly by the achievement of a specific goal or product. Making perfume or soaps did not need a lot of theory, just a good recipe and careful attention to detail. There was no standard way of naming materials and no periodic table that we could all agree on. It is often difficult to figure out exactly what a particular person was using. However, the science developed over the centuries by trial and error. Major progress was made toward putting chemistry on a solid foundation when Robert Boyle, 1637 to 1691, began his research in chemistry. Figure 1.1.3. He developed the basic ideas about the behavior of gases. He could then describe gases mathematically. Boyle, Boyle, also helped form the idea that small particles could combine to form molecules. Many years later, John Dalton used these ideas to develop the atomic theory. The field of chemistry began to develop rapidly in the 1700s. Joseph Priestley, who lived from 1733 to 1804, Priestley, isolated and characterized several gases: oxygen, carbon monoxide, and nitrous oxide. It was later discovered that nitrous oxide, laughing gas, worked as an anesthetic. This gas was used for that purpose for the first time in 1844 during a tooth extraction. Other gases discovered during that time were chlorine by C.W. Scheele, Scheele, who lived 1742 to 1786, and nitrogen by Antoine Lavoisier, Lavoisier, who lived 1743 to 1794. Lavoisier has been considered by many scholars to be the father of chemistry. Among other accomplishments, he discovered the role of oxygen in combination. Among other accomplishments, he discovered the role of oxygen in combustion and definitively formulated the law of conservation of matter. Chemists continued to discover new compounds in the 1800s. The science also began to develop a more theoretical foundation. John Dalton, who lived 1766 to 1844, put forth his atomic theory in 1807. This idea allowed chemists to think about chemistry in a much more systematic way. Amadeo Avogadro, Avogadro, who lived from 1776 to 1856, laid the groundwork for a more quantitative approach to chemistry by calculating the number of particles in a given amount of gas. A lot of effort was put forth in studying chemical reactions. These efforts led to new materials being produced. Following the invention of the battery by Alessandro Volta, Volta, who lived from 1745 to 1827, the field of electrochemistry, both theoretical and applications, developed through major contributions by Humphrey Davy, Davy, who lived from 1778 to 1829, and Michael Faraday, who lived from 1791 to 1867. Michael Faraday, Faraday. Other areas of the discipline also progressed rapidly. It would take a large book to cover developments in chemistry during the 20th century and up to today. One major area of expansion was in the area of chemistry. One major area of expansion was in the area of the chemistry of living processes. Research in photosynthesis in plants, the discovery and characterization of enzymes as biochemical catalysts, elucidation of the structures of biomolecules such as insulin and DNA. These efforts gave rise to an expansion. These efforts gave rise to an explosion of information in the field of biochemistry. The practical aspects of chemistry were not ignored. The work of Volta, Davy, and Faraday eventually led to the development of batteries that provided a source of electricity to power a number of devices. See Figure 1.4.1 on page 1.4.1. Figure 1.4, Figure 1.1.4, battery developed by Volta, CCBY SA 3.0 left, Guido B, and right KKKDC. So it shows the electrolyte, zinc, copper, and element, and those extra numbers and letters I read were for legal purposes, for those looking at the book. Charles Goodyear, 1800 to 1860, discovered the process of vulcanization, allowing a stable rubber product to be produced for the tires of all the vehicles we have today. Louis Pasteur, Pasteur, once again, Charles Goodyear, who lived from 1800 to 1860, Goodyer, discovered the process of vulcanization, allowing a stable rubber product to be produced for the tires of all the vehicles we have today. Louis Pasteur, Pasteur, who lived from 1822 to 1895, pioneered the use of heat sterilization to eliminate unwanted microorganisms in wine and milk. Alfred Nobel, who Nobel, who lived from 1833 to 1896, invented dynamite. You can see in figure 1.1.5. After his death, the fortune he made from this product was used to fund the Nobel Prizes in science and the humanities. J.W. Hyatt, Hyatt, who lived from 1837 to 1920, developed the first plastic. Leo Baekeland, Baekeland, who lived from 1863 to 1944, developed the first synthetic resin, widely used for inexpensive and sturdy dinnerware. Figure 1.1.5 Dynamite Explosion in Panama, Central America, 1908. Today, chemistry continues to be essential to the development of new materials and technologies, from semiconductors for electronics to powerful new medicines and beyond. Summary: chemistry is the study of matter and the changes it undergoes and considers both macroscopic and microscopic information. Matter is anything that has mass and occupies space. The five main disciplines of chemistry are physical chemistry, organic chemistry, inorganic chemistry, analytical chemistry, and biochemistry. Many civilizations contributed to the growth of chemistry. A lot of early chemical research focused on practical uses. Basic chemistry theories were developed during the 19th century. New materials and batteries are a few of the products of modern chemistry. Contributions and attributions. This page was constructed from content by the following contributors and edited topically or extensively by the LibreText development team to meet platform style, presentation, and quality. Marissa Alviar Agnew, Sacramento City College, ALVIAR hyphen AGNEU, Henry Agnew, UC Davis. End of section 1.1.